Right, we are live now.
Oh, sweet. Cheers, everyone. Or just to you, Pranay, if you're the only one on the live
Abhimanyu
stream.
is there. Hi,
Okay.
Abhimanyu. Abhimanyu has been a regular visitor of the community. He's been I don't know, around for more than 2 to 3 years now.
Mm-hmm.
Yeah.
Hey, Abhimanyu.
Let's see how many people are live.
I'm just going to stop presenting for a bit.
Yeah.
Hey, Akash. Hey, Lakshay.
Hey everyone. Um. Yes. Yes.
Yeah, let's give it about 2 minutes and then maybe we get rolling and people can catch up when they catch up.
Right.
So everyone who's still on, just to kill time for a bit, what have you all been doing all this past week? How's everything been with you? I know this is like super uncertain times, but what's happening? What have you been busy with?
Is everyone coping up with the times all right, or do you need any help? How's the scenario around your society, your community? Okay. I think a minute more and we should get rolling.
Yeah. So Pranay, what have you been up to? Let's just spend some time killing, talking to each other.
What? Work. I think it's kind of fortunate situation. I would say it's rather a privilege to have been able to continue work. So
Yep.
yeah, um, it's a lot of days consume. Like Monday to Friday, it's occupied, right? You don't even realize how the weeks
Right.
are being spent. So
Mm-hmm. That's sweet, man. Yeah, but I totally agree with you about the privilege bit, right? I mean, I for real, I consider myself privileged that I have a job right now. So yeah,
yeah,
uh,
so
but yeah, I know that that a lot of people and in fact Abhimanyu also mentioned about the pay cuts and everything. But I think let's just look at the bright side. You still have something coming in, some sort of cash flow coming in. But yeah, these are tough times, man. And I think mostly it's gonna unravel into something much more beautiful when all of this stops, right? Just look at 2008, the depression back in 2008, and all the other bits that have been happening all throughout, right? We've always like human civilization has always come out stronger than before. So yeah, I think this is temporary.
that's true. Yeah. Okay. I
Yeah,
think
I
we
think
can start.
let's
Let's
keep rolling.
let's get rolling.
Let me share my screen, right? Okay, and can you see my screen?
Yep.
All right, Cool. So I'm gonna take ahead and Pranay fill me in and keep me honest when I talk about what we're doing here. So first of all, welcome on Coffee on Cloud. As you can see, we have our coffee mugs, uh, and today we're gonna be talking a lot about BigQuery, right? And we'll get to what Coffee on Cloud is. We'll get to what BigQuery is in a bit, right? But then the main intention of having this video series or like having these small meetups or rather micro meetups is basically to talk about one of the Google Cloud services every week, right? And then essentially just talk from our experience how say for example BigQuery has been for me as like a Google Cloud developer or for Pranay as like a Google Cloud architect, and essentially try and put those down into like a small video and kind of share our experiences through. Um, so yeah, Pranay, do you want to formally introduce yourself?
Okay. Hi, everyone. My name is Pranay. I work as a cloud architect with Media Agility. It's a digital consulting company. On the sidelines, I also like to contribute to the community in as as a organizer for GDG Cloud. Yeah, so that's what I do. I am a Google Cloud certified individual and have, I mean, it's been about close to 2 years that I've been working with GCP as my go-to technology. So yeah, that's that.
Sweet. Yeah, a little bit about me. I'm Vaibhav, and I work as a data scientist with Deloitte Consulting. My day-to-day work is at the cross section of like machine learning and Google Cloud, and I basically work with technology and consumer sector clients to get them one on Google Cloud and also build machine learning solutions for them on Google Cloud. I also happen to be a co-organizer of GDG Cloud New Delhi with Pranay. And back when we were allowed to get back together physically, we used to hold a couple of meetups, and I used to talk about machine learning and GCP stuff. But yeah, hopefully I'll get to meet you all soon. So that's that about us. Now enough trash about us. What is Coffee on Cloud, right? It's, as I said before, it's an attempt by both Pranay and I to be able to democratize Google Cloud services and essentially just share personal stories about how we've kind of worked on these services, built something using these services, and essentially use that experience to give you like a view that you might not find online as quickly. Again, like if I just talk about one service of Google Cloud, it'll probably take us like 6 to 7 hours just talking about each and every individual features of it. Um, GCP services are like very robust and like very verbose just in terms of their documentation and their services. So we're just gonna cover like um, the ones that we keep on using more often and our clients keep on using more often. And yeah, if you have any feedback throughout the session, just hit the comment section and we'll get back to you. If in case you want to, we'll also be looking at live tweets. So on each of the slides below, you would see Pranay's and mine Twitter handle. So you can tweet your questions to us and we can answer you as well. So yeah, either way, if you have any questions, just hit back out to us. Pranay, do you want to walk us through what we're going to cover today?
All right. So today, as Webhub suggested, we are going to talk about BigQuery. What is BigQuery? What are its key features? How can um we keep data secure there? What are the main major use cases where people are using BigQuery? Right. I'm going to talk about best practices, and we are going to take questions in the end. So yeah, it's going to be an open forum after we are done with the presentation. Yeah.
Cool. Getting right into the meat of BigQuery, right? Now, every time I talk to someone about BigQuery, there are like these couple of keywords that pop in, right? Um, the first one of those is that it is petabyte scale, right? For those of you who do not know, BigQuery is based off of this Google tech, which is called Dremel, right? And Dremel is the one which is also supporting Google search. So pretty much every time that you search, hey, how do I make popcorn? Hey, how do I make pancakes? Or how do I solve X, error in Python, Go, Java, and whatever. And when you get results as quickly as couple of milliseconds, that's basically Dremel and like couple other Google services working in tandem with each other. So BigQuery, in a way, essentially is a part of how Google search works as well. So if it can handle a scale that huge of of Google search, then for sure it can handle any petabyte, zettabyte, or exabyte kind of scale that you push at it.
Yeah. Um, the next point is that it's fully managed. By fully managed, we mean that you don't have to do anything. You just have to bring in your data, and you can simply run your queries against it. Uh, so that is the power. It scales automatically. You don't have to take care of network. You don't have to take care of security. You don't have to manage anything. Just bring in your data, and data can also be imported in multiple formats, right? So all of that, everything, schema handling, everything is done for you. All you have to do is just come in and just hit it with your queries, and BigQuery will have your answers in no time.
Yep, and just to add on that, right? So for those of you who've worked with MySQL Server or Oracle SQL or Cassandra, or basically all the other kind of industry giants, right? There's like a lot of overhead involved in terms of maintaining the indexes, making sure that your data is sharded properly, making sure that there are no hotspots in your overall warehouse, and you're querying perfectly, and so on and so forth. uh, that all is taken care of by Google, right? So all Google wants is essentially to have your data within BigQuery, right? And then for you to be able to write like a simple select star from blah 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 table, and with XYZ conditions, and you would be good to go, right? So there's legit zero DevOps requirement when it comes to BigQuery, right? Coming to the third point, right? BigQuery is an analytical data warehousing solution. What we mean by that is BigQuery is like a columnar database, and it's extremely fast when it comes to aggregating your data, building reports on your data, or just like merely crunching terabytes and terabytes of data. Just to give you an example, just before this live cast, Pranay and I, we were on our screen share, and we were just going through a couple of queries, and I ran a query which crunched about a terabyte of data in less than 2 seconds. Right? That's the power of it. So you're not limited um, by the amount of data you push at BigQuery, right? So throw whatever you want to throw at it, and it will be able to crunch it in a very, very quick turnaround time. So yeah.
Right. And that's a very interesting perspective. Uh, I mean, again, as I have suggested, right, from previous experiences as well, I can suggest that when I was trying to crunch, I remember it was about like 30 terabytes of data, and I was able to query it under 15 seconds or so. So that is the scale that
Right.
it can. It would be otherwise very hard. And as previously mentioned, it's also a serverless platform. So all I had to do was bring in data in any CSV format and just run queries against it. So that is what the power it could offer me. But not only, a lot of these options, when you talk about data warehousing solutions in the market, um, a lot of these options also come with the cost overhead, right? There's a hardware cost attached to it. At least some of the softwares require a large amount of hardware. BigQuery would even work for smaller data sets, which is why it's also cost effective. One of the most lucrative points when you talk about BigQuery is that, and when people what where people really start to see where it is shining is uh, when you tell them not only you can do this data warehousing or data lake solutions faster, you can also do it cheaper. So cost effective becomes a very huge point there. And BigQuery, you're only charged for uh, your storage and the amount of data scanned, which is fairly cheap. It's if it's it, and storage is at the price of cloud storage, right? If you store it regional, whatever cloud storage regional cost is, that is what you'd be charged. And if you store it for and if you store it multi-regional, you just charge for the continental again. That is 26 cents per TV. If you want to scan data, it's like $5, 5 terabytes. Oh, sorry,
$5
dollars
per
$5 a terabyte. Yeah, that's pretty neat, right? And nothing else. All it's doing is that uh, charging you on, and it's a pay as you go model. So you only get what you only are charged for what you pay, for what you use. The fun part is that 10 gigabytes of storage and a terabyte of querying is free every month. So if you have a smaller workload, it's fairly easy to get started with. You don't even need a credit card to sign up for it. So you can practically have your basic elementary, if you want to just simply check it out, it's fairly easier to get started.
Yep, and yeah, I mean it's dirt cheap if you have a lot of data, right? You don't have to pay for getting your data into a BigQuery warehouse, right? You only pay for whatever you scan, right? And a terabyte is a lot when you, especially when you have small data sets. But if you have large, even then you're not paying for maintaining indexes. It automatically creates your indexes. You're not paying for any of those server costs and all of that. It's literally just like $5 per terabyte, right? So that's I believe that's a very good value proposition, and something which defines Google Cloud BigQuery apart, and like sets it apart from its competition as well. Yeah, and not just that, right? It offers really nice real-time analytics capabilities, right? um, what we mean by that is, as soon as you stream your data in, within 1 to 2 minutes, your data would be available for all of your downstream applications to be able to use that data in, right? Those downstream applications could be machine learning models, BI visualization tools, and so on and so forth, right? So it has pretty nice support for real time analytics. It's not that, and also another quick thing, right? So there is no concept of cursors here within BigQuery, right? So for those of you who've used like Microsoft SQL or Oracle SQL, you would have seen that you have to create like a cursor object, right? And every time you create a cursor object, there are like limited number of thread pools that your your application can sort of connect with, and more often than not you would start reaching like thread not found error or thread pool exhausted errors and so on and so forth. That's not the case here, right? You can basically run 1000 concurrent queries, and BigQuery would not even bat an eye. So yeah, so it's extremely fast, it's extremely flexible. It lets you query as many number of times as you want to.
Right. A little joke here when Vaibhav said that, terabyte is a lot of data. And I used to believe the same. I started using BigQuery and terabyte became like, I don't know, gigabyte or something like that. Terabyte, I don't know. It's really got no value when you talk about applications at such large scale, and then you have all this tooling that can process it
Yep.
all and crunch it in no time. It's
Yep.
fairly easier, right? And see how many problems people are able to solve, um, simply because they have so much data and this kind of tooling available to them. What also makes these kind of tooling, there's a great part about it, that it's easier to use, right? Any great tooling has uh, a, a very basic property that it should be easier to use and easy to get on with. If you are to use BigQuery, right, there are so many multiple ways that you can connect with it. Of course, there's a GUI based web console that's available, but then you can also query via using your client libraries. There are client libraries for multiple applications. There's even a client library for C++, right? So that's the kind of support they're able to offer. Let alone, of course, Python, Go, Ruby, Java. These applications are definitely supported. Um, there's a client library. There are, if you want to make an API call directly, that mechanism is also available. And right, last but not least, there's also a command line tool available. If you want, you can query your data, you can run operations on BigQuery right there using command line tool. Think of it, right? You can put it all together in a bash script and run that script howsoever you want, and it'll keep your data sets will be managed. Running bash would be far more easier than uh, I mean, if you are in some kind of system maintenance kind of setting, running bash is way more easier than running any other Python script or so.
Yep.
Yeah, that's there.
Yeah, and like just talk about this programmatic interaction a bit more, right? It's you won't even believe it's like with literally just 4 or 5 lines of Python code, you would be able to connect your application with BigQuery, get the data in, or make those in updates or insert some data in, and whatnot. It's literally as simple as that. You don't have to like set like a context variable, no cursor variables, and all of that. And like especially for me, like coming from a background of using like these transactional data warehouses, and like setting up these thread pools, and all of that, it was a bit overwhelming, right? Because you just have to write your code in such a way that you put a try catch everywhere, you're handling all the exceptions and whatnot. And it was a painful task to write that code and maintain that code and so on and so forth. But with the Google Tech and their engineering team, it's really nice, and it's quite seamless as to how you can use your Python BigQuery client library and like connect with BigQuery and get your data out. Last but not the least, before we get to some live demo, just talking about monitoring and logging, right? BigQuery provides you like this one console page wherein you can monitor who within your team is using, how much data, or what kind of queries are they running, which tables are they hitting more often, where's your billing at, and you can put curbs on how much data can every person crunch, how much money can you overall push in, and yeah, it's actually quite neat, right? It's just one small admin dashboard that you can access everything within BigQuery from, right? Uh, Last, it has like really nice logging support, right? So for every query that you run, every time there's an exception that your query hits, or like maybe it does not run at the scheduled time and whatnot, it would be logged within Stackdriver of your project, right? What that means is you would always have like a ground truth log of whatever is happening with your BigQuery warehouse, whatever queries are being run, and so on, right? So it's actually quite neat in that sense. Brian, do you want to add something there?
Yeah, right. So as it not only BigQuery, you can see what queries have you run. There's also this mechanism that you can query your previous queries, right? So if you want to count how many times this particular query has been run in the past, it you can drill it down to that last point. So that is, I think, a very cool and nifty feature to have, because so many times I just want to see on what date was this query run and want to go back and see what basically changed my data, right? And I would have that view. I would have those values. So it kind of makes very easy for someone who wants to do an audit to navigate. So that's there. Another thing, right? Maybe we should have talked about this earlier. There's this one case wherein one of my friends, talk about programmatic interaction. One of my friends worked somewhere in a fintech organization, and another competition that BigQuery, right? Because we talked about Dremel, and Dremel is kind of derived from an Hadoop-based ecosystem.
Yep.
Um, so when we Hive again is something that utilizes your standard SQL, and you can query your data. One of the this point kind of covers through the entire aspect, because if you are running in a system like Hive, right? Even if you're talking about open source, and let's not consider the uh, and even if we don't consider the OEM costs from, say, Microsoft, SAP, or Oracle, or any other brand or make for that matter, maintaining that open source software requires a certain amount of hardware. There's a
Right.
storage cost attached to it, right? You have to maintain it, and then it's also slow because you're bound by those constraints, right?
Right.
You're not If you're not using something that is meant to, something like, let's say, any other service that is optimized for those environments, even something like Hive would really fails, and it really gets frustrating, because again, and talk about programmatic interaction, it's fairly harder to navigate and harder to use than what Google has to offer with BigQuery. Uh, and it also, again, all these points where it's there are tooling wherein you can see things. You can see not only your history, the entire project's history, provided you have sufficient access to it. So yeah, pretty neat features there.
Yep, and all good points, right? But enough presentation, right? Let's look at how BigQuery looks like out in the wild. Just a quick check, Prani, you can see my screen, right?
Yep, yep.
Okay, cool. So this is how the BigQuery console looks like, right? And just a quick thing for the sake of reproducibility, we've just created like a simple account, and this is a sandbox account. So all of you who are on the live stream right now, or anyone who watches this video later on, you can basically go on console.cloud.google.com, create a free account, and go hit sandbox, right? It's free of course. You don't even need your credit card to be able to run your um, queries, and you can like take BigQuery out for a spin, right? So what and just let's just quickly just go over the sorry. Let's just quickly go over the features of BigQuery as you see on the console, right? So as you can see that your personal query history is available here. I just ran two queries, so it's available here. You can look at your entire project history as well. So whosoever has run whatever queries, they would pop up in this is a project that is kind of shared across with multiple people. So you can see that they have ran their own fair share of queries there. This is where you execute your queries from. Let's see if we can query a table, right? Let's look at GP queries. I'm able to open that. Okay, one sec. There's this table contracts, and within that there is raw, right? So as soon as I clicked on raw, you can see that it automatically popped up the schema of raw, right? So you can see all the field names here, right? It's a huge table. You can see what is their type. You can see what's their mode. Can they have null values or not, right? And there's this another thing called policy tags, right? And we'll cover these policy tags in a bit, but what in like just 10 seconds, what policy tags are that you can basically set access controls for each and every column, right? So say for example, if you don't want the field dollar obligated to be viewed by Pranay because I don't trust him, so then you can basically set a policy tag that Pranay should not be able to view dollars obligated, right? And he would get access to the entire table except dollars obligated, right? So you can also have column level sort of policy set in. This is a relatively new feature. It's still in beta, but this is really nice, especially if you work in healthcare or like a regulated industry, like a financial um, industry and like fintech and then so on and so forth, right? And if I go over details, getting a lot of lag here on my screen. I don't know if it's because I'm um, sharing, but you can see that there's like all of this info, right? That the overall size of the table is 77.35 gigabytes. Overall number of rows are 44.5 million. This was created in 23rd May 2016. Um, Last modified in 13 June and so on, right? Let's see, and then this is probably one of the really nice features that you can quickly preview the table to get a feel of how the table looks like, right? So you can see that there's a unique transaction ID, and it's probably like a UUID kind of put in here. You can see the transaction status, dollars obligated, um, and so on. Uh, let's see if we can quickly query the table. So I go to query table. As soon as I click query table, it would automatically create like a small query for me and put a limit 1000, right? So that I don't like scan the entire table and end up crunching like entire 77 gigs of data. I only do it for like a small size of it, right? So let's see if I if I use, okay, I'm facing a lot of lag here. Sorry about that.
It's fine.
Yeah, it's kind of taking ages to pop up. 1 second. Let me just go all the way to the back. Okay, so let me clear this up. Ah, the lag is killing me. So let's say I want to get the unique transaction ID and the dollars obligated from the contracts table, right? And just limit it to 1000. Just want to see like how several these columns are, right? So I can just press Control Enter or just press Run, and it would automatically start running the query. Um, my screen's stuck, but I already have the results kind of popping up on my screen. I don't know if you can see it. Um,
No, not yet. It's still
oh,
running. You
oh,
can
it's still
see.
running. Yeah, I just realized. I was looking at the preview. I don't know. Maybe it's because of my internet connection. I don't know. But this is taking a lot more time than it should.
Maybe I'll present it just something
Sure,
around those.
sure. I'll do that.
So yeah, what we meant to imply was right. You can basically query run a basic query. It's basically selecting the name and the gender. It's basically order of uh, how common a name is, right? And it's sorting it by uh, the name and the gender. So if I do like a run again, it scanned like so as you can see here, right? I ran this query previously. It ran for 5.8 seconds, and the number that it gave me was 90. It scanned 99.8 megabytes, and the number that it gave me was 5.8 seconds. On
Yeah.
larger data sets, this number would still remain around this 5 to 6. Like even if this was 100 gigabytes, right? This amount would still remain the same. This number of time taken would still remain the same. So that is what we wanted to stress on. A lot of times you don't necessarily have to write Python code or say use it. You just use this console to get whatever you want,
Yep.
and that's that. Uh, so
Yeah. And
Biswanath, yeah, sorry, yeah, please continue,
just a
guys.
quick thing, right? So Pranay, if you can just like quickly zoom in a bit to the screen. It's
Yeah.
Yeah. So right, so just want to emphasize on the fact that it was literally just this, right? Just this small 9 line SQL code, and also if you look at it, right, the overall BigQuery, like what Pranay is using here is basically a BigQuery public data set, right? BigQuery almost every month or every other month they would release a new public data set which they keep on updating every now and then. So they have something for Bitcoin prices, they have something for stock markets, they have something for USA names. This USA names data set has all the names that people have named their babies in the USA, all the way from like 1900 to I think 2013 or 2014, right? And it's actually quite nifty to see that no matter how much data you have, it'll automatically scale up, right? Also, Pranay, if you can go towards the left, right, to the features column. Yeah. If we just see here, right, you can see that you can basically look at your query history. You can also save these queries, right? So once you save these queries, these queries can be available either to your entire project or just to you, and you can then sort of retrieve them later on, and so on, right? There is job history through which you can look at what query was run and when. There are transfers, which means that how your data is getting into BigQuery. You can like sort of figure that out. whether it's coming from cloud storage, whether it's coming from some other SQL server on your GCP environment. So you can basically track those from transfers. One of the cool things here is that you can schedule your queries, right? So say for example, you're sort of scraping a lot of data from Twitter, right? I'm just giving an example. Say you're scraping a lot of data from Twitter, right? All of this data gets into your BigQuery, raw layer, right? Which is the first table, right? Now every day at 6 a.m. you want to process these tweets and put them into a new table which is called tweets underscore refined, right? So you can basically write a query for it, click on schedule queries, set a time for it, and it will every day it will run at 6 a.m. Right? So you don't have to like write a cron job for it. You don't have to write anything else. You can define your own flows here. It's actually quite a nifty feature, and I, for example, end up using it a lot more than required. I pretty much automate everything using scheduled queries, right? And you can run it all the way till your visualization layer, right? So like or your like downstream layer. Just keep on processing your data through and through. Um, yeah, and then there's reservations in BI engine. I think we can skip through it right now and like talk about it towards the end because we're already 36 minutes into the live stream and we're just at the first slide.
Yeah, cool. So Biswanath had a question that how can we do a view? It's like you whatever you query, like if whatever you write, all you have to is hit this button, save view to whatever view do you want to save it. I want to save it to GDG Cloud New Delhi. I'll maybe add it to a data set, whatever data set that I want to add it to. I don't think I have a data set yet. But yeah, if I want to add a view, I can add it simply right here using simply that button. That is it. That is it. Nothing else. Um, I'll maybe switch back and give the stream to Weber.
Okay, I'm actually not sharing right now. Just give me 1 second. Okay, I'm sharing. If you can put me up. Cool. So yeah, now we actually Pranay, you can share your screen and we can just go through key features. How about that?
Cool.
Okay.
Is it visible?
Yep, it's visible.
Okay, so the next is data definition and manipulation language. This is kind of cool right now because previously there was a limit to it. And basically now you can add, manipulate your data, create data sets, and there's no limit to it for how much you can do. And it's kind of pretty cool uh, because a lot many times, right, people don't want to hit the threshold that BigQuery or Google had to offer. So now you can run your basic create dataset statement, create table statements. You can insert, update, and merge. Those commands also run appropriately. So that proper DDL and DML definition, it's entirely supported on BigQuery.
Yep,
Yeah.
yeah, and we've now kind of moved past the introduction to BigQuery and we're talking about key features here. And yeah, Pranay mentioned about standard SQL. He spoke about how views can be created, and just want to spend like one more minute on DDLs and DMLs, right? Generally, when you look at like large scale, databases and large scale kind of warehouses, you would see that there is a lot of there's like a lot of restrictions put in on it, right? Meaning how many number of updates can you do, how many number of deletions can you do in a day, because they can either optimize for analytics or they can optimize for insertions and deletions and updates, right? Like that's the biggest difference between transactional data set database and an analytical database, right? What BigQuery now has done is up until like a couple of months back, BigQuery had like a hard limit at how many number of updates you can do, how many number of deletions you can do. But now it's kind of evolved, and the way their tech has evolved is now you can pretty much make unlimited updates. You can pretty much make unlimited deletes. You can have unlimited inserts. Inserts previously also had unlimited, but the fact of the matter is that you can basically treat BigQuery now as a transactional analytical warehouse as well, right? And that's a very unique proposition. Even like other AWS or Azure counterparts also do not have that level of flexibility and offering in that sense.
Right.
So yeah, and yeah, we so I'm just gonna cover federated datasets first, and then I'm gonna do like a live demo, like a small live demo of client libraries and UDFs, right? Federated datasets is as a concept is a very new concept, right? It's what it helps you do is it helps you create external tables within BigQuery, right? How that's helpful is take for example you have like a CSV or a JSON or like some sort of file that's kind of put in your cloud storage, right? Now you quickly want to see how that file looks like, right? How that file looks like. Probably query it and just see what kind of columns you have, what kind of rows you have, and so on. You don't have to import that into BigQuery anymore. You can create a federated data set which would point to a Google Cloud Storage bucket, right? And you would be able to automatically be able to query all the raw files that are put into your cloud storage, right? And that's something which the likes of Oracle, the likes of MySQL and Redshift and all of these offer, but they do not work at the scale at which you would expect them to. Federated dataset, I personally have tested them on more than 10,000 files, and it works quite well. So it's something quite cool when you just want to get a feel of how your data looks like, and if your client wants to not go through the pain of getting the data into BigQuery first and just be able to um, you know uh, get stuff in. So now I'm going to quickly walk you through what UDFs and parameters do. Pranay, if you can put me on. All right. So we um, there's this really nice thing which BigQuery gives you, right? In terms of just querying, right, is that it since it does not support procedures and all of that stuff, what it gives you the capability to do is write user defined functions, right? So you can write your user defined functions either in SQL, right, or you can write them in JavaScript, right, or Lua as well. I don't know if Lua is out for public as well, but at least in the Dremel counterpart of it, you can write UDFs in Lua as well. So I'm just going to quickly walk you through a couple of these simple ones, right? And I have these queries written in my Google Docs. I'm just going to copy one real quick and show it to you how it looks. This is a SQL UDF, right? If we just walk through what the query does is I'm creating a temp function. Naming it add. Let me, one second. Okay. I think this should be good. So I'm creating a temp function which is add 4 and divide. So it basically takes two variables of int 64 bytes and sorry, int 60 int 64 type, and then it basically adds 4 to x and divides by y, right? Now with a with clause, I'm basically creating one row which has the column name is the name of the table is numbers, and I'm creating a column called val, and it has 1, 3, 4, and 5 as the input rows to it, right? And over here I'm doing nothing but basically calling the numbers table, as you can see here, which we created in line 3. And I am selecting val, and I'm calling add 4 and divide function, and passing val as x and 2 as y, right? Let's hit um, let's hit run and see how it looks like. Yeah, so you can see here my query is done executing, right? And you can see that it basically took 0.3 seconds. 0 bytes were processed because this is literally nothing. And you can see that I had 1, 3, 4, and 5 as the as the values, and the result is basically 1 plus 4 by uh, you know 2. So that's 2.5, 3.5, 4.0, 4.5, right? It was it's quite neat and nifty, right? You can basically write like a SQL function here and then be able to call it out in your SQL query itself. Now I know that all the other SQL offerings also offer you SQL functions, but there's something more to it as well, right? Let's look at how you can create like a simple JavaScript function, right? And this gives you more flexibility because now you can programmatically write loops. You can do like large array based computations as well, and whatnot. Basically, you're providing the capability to write like an end-to-end programming code within BigQuery and then be able to execute it, right? So this is huge in terms of just getting like enhancing what you can do um, with your BigQuery tables itself, right? So let's do a quick deep dive into what this JavaScript function does, right? So if you see here, I'm creating a temporary function. It's called multiply inputs, right? So it basically takes two variables, x and y, right? And it returns like it returns another it returns a variable back, right? It returns x star y back, and you can see that I've mentioned the language as JS, right? I can also put in Lua here, but it does not support any other languages like Python and stuff. I think they're in beta, but not right now. So you can see here what I'm doing is I'm again creating like a small temporary table. I'm creating two columns x and y within numbers, and there is x has 1, 2, and 3, y has 5, 10, and 15. And then all I'm doing towards the end is I'm selecting x, y, and the multiplication of the two, right? Now let's hit run and see how this looks like. So let me pull this up and see. Perfect, right? Within zero point 0.5 seconds I was able to um, get the product of x and y. Now I know like this feels quite trivial, right? But just think of it when you're like going through multiple nested sort of JSONs or like multiple nested arrays, and you're performing multiple um, sort of not joins per se, but say matrix calculations within like one column. JavaScript kind of comes really handy. Yes, it's slow, but it sort of augments the existing capability of BigQuery, and opens it to new potential as well, right? So you can see that one into 5 is 5, 2 into 10 is 20, 3 into 15 is 45, and so on and so forth. I have a couple more examples, but in the interest of time, I'm gonna get back to this, right? One thing which I did not talk about up until now was how do you programmatically access BigQuery, right? So what you see right now, what's loading on my screen is basically a Google Cloud Shell. Now, this is by far, in my opinion, one of the most used um, components of Google Cloud, right? What Google Cloud Shell is, it's basically a very mini VM, right? Which gets provisioned to you as soon as you click this button here, right? Where my mouse is. And you can, like, as you can see, right, at the bottom of my screen, there's this VM, right? Now I can this is like a fully functioning VM. I can say hello Google Cloud, and it has bash installed in it. If I click on Python, you can see that I can basically write fully functional Python code, and it works, right? Um, let's see if we can, I don't know how to increase the size here of this.
You could
Let me
zoom
see.
in on it specifically.
Yeah, I think this should work, right? Um, so let's see if we can create like a quick file, right, which can connect to BigQuery, and then we can get some pull some data from it out, right? Uh, cool. So I have this uh, small code written in. I'll just give you a walkthrough of this code in a bit. But let me just quickly create vi test pq.py. Yes, I'm a vi guy. Hopefully, I will be able to exit out of here. Uh, let's do WQ. Okay, let's look at the code again just to see what's happening there. Um, if you see the screen, right, what's happening is I'm calling the client library in the first line, right? It's from google.cloud import BigQuery. So I'm calling the BigQuery client API, right? And then I've created this small function. Um, this function queries a BigQuery public data set about Stack Overflow and the questions that have been posted on Stack Overflow, right? And all I'm doing is I'm basically going through this table, right? And I'm searching for all the Stack Overflow questions which have had like a Google BigQuery tag, right? And then I'm getting those and I'm like ordering them by their view count, and then I'm fetching the first 10 of those, right? And then I'm printing those here. You can see here, and then in my main function, I'm essentially calling this function all over again, right? So let's see if we can run this. Um, Hopefully it would not error out. You can see it's giving me standard errors, and you can see what it gave me are these Stack Overflow questions, right? Let's see if I can click one and open it. Wow. And you can see it basically gave me the URL of the most viewed question on BigQuery. The most viewed question on BigQuery on Stack Overflow is, can we cast a type in BigQuery? This was asked 6 years ago, and this is hilarious because this is the first thing you see when you get to documentation. But apparently, a lot of people faced this issue back in 6 years back.
Six
Let's look at
2,000 times.
yeah. Let's look at something else. This is the third or fourth most viewed question. It's BigQuery count distinct value versus count value. It's saying there is some discrepancies in terms of the query. Then this person has basically explained how and why count distinct is just a statistical approximation, and it's not the exact one, and why you should use something else. Um, and so on. And yeah, there's an update that this has been fixed. So yeah, I mean, just want to go back to the code real quick, right? Just with what these are, what, like about 10-15 lines of code. This is your SQL query, wherein all you're doing is just selecting and getting the ID of your Stack Overflow question. You're able to sort of query it within your comfort zone of Python, get the results back in, and then you can do like all sort of things that you want to do there, right? You want to answer these questions, you want to just put these questions on your website, do whatever you want to do, you can do it. The fact of the matter is that it's literally just 5 to 10 lines of code in Python to be able to do that. Yeah, pretty cool stuff.
I yeah, it's a pretty cool tool. That is what, right. We started off this conversation and we said that it's such a comprehensive tool. There's never enough to talk about it. We're already in, I don't know, 55 minutes in. We still think that we skipped out on a lot of stuff, right? Because
Yeah,
we not
yeah.
cool. Maybe we should just go through the remaining set and just try to wrap it
Yeah,
up.
sure. Yeah, I'll try to take less time. So yeah, so now that we know what BigQuery is, we know what are its key features, right? Let's talk about security on cloud, right? Generally, a lot of industries, both like Pranay and I, we've seen in the industry, in the market, that people are generally still, especially in India and like APAC region in specific, right? They're a bit hesitant of cloud, right? There is always this how should I put it? There's always this kind of friction,
Apprehension.
yeah,
Yeah.
apprehension, right? That hey, is the cloud secure or not, right? And those are all good points, right? So just to address those, we've kind of put together 4 points on how it works, like, right? So just talking about the first one, right? It's about IAM policies. IAM is identity and access management policies within BigQuery, right? What what the IAM policies help you do on Google Cloud is basically be able to grant access to any person on your project as to what they can do with BigQuery. Can they read BigQuery datasets? Can they write into BigQuery datasets? Can they delete tables? Can they insert into those tables, and all of that stuff, right? All of that your project administrator should be able to add, remove, and sort of manage from just one pane within IAM, right? And that's pretty cool because you don't need to have like separate sort of IAM policies, or like a separate page for BigQuery or other Google Cloud services. You can all do it using just one page. Over to you, Pranay. Okay, so
Cool. Uh,
let me take this one too. Yeah.
yeah,
uh,
yeah, yeah.
Cool. So this the column level security kind of ties down to that one BigQuery tag which I was talking about a while back, right? Let me just quickly go there if that's available. Um, So if you can see here, right, like as soon as I opened the GP queries, you can see here that there are field names, there are type, there are mode, and there's a policy tag, right? And as I mentioned before, policy tags help you sort of put column level security checks on your BigQuery tables, right? So you can basically sort of mark all the columns which are PII, all the columns which are PHI, all the columns that you don't want everyone to get access to, but a limited set of people. You can all define using policy tags within BigQuery. So that's something which is still in beta, but again, that's miles apart from the competition. They peop, a lot of competitor kind of warehouses do offer something like this, but they're nearly not as robust as the column level securities offered by Google. Over to
Yeah.
you, Pranay.
Right. Um, it on column level security, they're also difficult to manage, because when you have larger data sets, it kind of gets difficult to manage. So this mechanism of simply adding a tag to a particular column, and then yeah, you have everything secure. Yeah, on BigQuery you can encrypt your data. You can have you can encrypt your data via Cloud KMS. You can either have your own key, or you can use the Google managed key, and so your data security stays under your control. That is something that you can manage. Um, I'll just maybe I'll switch over to my screen. Yeah. Right. The last point is that if you have personally identifiable information, right, maybe you have names, phone numbers, addresses, Cloud DLP, again, data loss prevention, it's basically an API and it's tightly integrated with BigQuery. So anytime you have that kind of data, you can use your DLP to clean it out or maybe prohibit it from people from seeing it. So that kind of protection is also available. I will I like to show some very, these are certain, let's move on to downstream applications. There are certain applications in BigQuery. I just want to talk about two of them. Maybe I'll hand over to Webho after this. There's this one called BigQuery GIS, right? Which means that you can query your geospatial information systems based anything geolocated. And BigQuery comes with that capability built in. Right? So what this is a simple standard query, which is basically querying this data set, right? And it's basically pointing out the number of uh, it's basically pointing out the bike stations in New York that have more than 30 bikes available. So if I run this, right, it, as you can see, it's only querying 19.1 kilobytes, right? And the responses return between 0.3 seconds. This data set is much larger, but then
Yeah.
because it is partitioned and clustered, it's right, which is why you can see not only you save money, you also optimize on the performance aspect as well. So 19.1 kilobytes is nothing. Um, the fun part is I can visualize it. This is again a tool by Google. Its code is available on GitHub. This is the same query. If I run this, right, BigQuery BigQuery, and whatever results that you get, you can basically visualize it on this map kind of thing. And it is not only able to point out points, but it can also draw polygons. Draw You can literally draw a map from what how far is each point from this. So if you zoom in, right, you see these red dots. These This is the kind of map that you can create. You can basically, and if I wanted to calculate a point distance between 2 points, that is also possible. And then I can style it and do other stuff. That kind of thing is also possible. The next aspect that I wanted to talk about was large scale analytics. We started off with this conversation and started telling about BigQuery. One of the major use cases people use BigQuery is that they have tons and tons of data, right? They have terabytes, not even petabytes of data. I don't know which of these, either of these, Twitter or Spotify, but they used to run a Hadoop query, and it would take 2 weeks for them to get the report back. And
Right.
they were like, I don't know, Spotify processes 4 petabytes of data every day on BigQuery, and when they were running this query that took about 2 weeks to return the result, when they onboarded onto BigQuery, that time was brought down to 12 minutes. That is insane, in my opinion, right? From when you're spending, when you can run a query twice only in a month, and on the other hand, right, you can run it, I don't know, like 5 times an hour, if that's the way you look at it. So it's kind of that is the scale that we are talking about. And so many aspects that adding geo information to it is a value add-on, because people already had that data, but they had to export that data to, something like, again, say PostGIS or something, so that they
Right.
could work on it. It's built on it, and it's far more easier to work through it. Yeah.
Yeah,
um,
and just to like quickly add on there, right? So the BigQuery GeoWiz thing is something which is like much more powerful than than you just see on your screen, right? You can basically plot like tens of thousands of points on your screen in real time straight from BigQuery, right? Up until now, if you look at the overall flow, how it would look like is you would, sort of go through all of your GeoWiz data, right? You will get your longitude, latitude. You'll have like a shape file which will have all the coordinates of your, whatever area that you were kind of looking at, right? And then you would take that shape file, you would put all those location and coordinates on that shape file using, say, Python, Java, or some sort of those, some sort of a tooling like that. But what BigQuery gives you is like a way to be able to get those visualizations, like, or basically be able to analyze all that geo data right from the console itself. So that's I think very powerful, and again, class apart from all the other competition.
right, cool. um, Next, Trevor, I think you can talk about,
Sure,
I'll hand you over, and you can talk about the ML and BI capacities.
sure. Is my screen up?
Yep.
All right. So what I'm going to talk about is BigQuery ML and BigQuery BI engine, right? So first I'm going to talk about BigQuery BI engine, and then I'm going to get into like a demo of BigQuery ML. What BigQuery BI engine does is it basically provides you with like an in-memory um, service through which you can expedite all of the analysis that you're doing, right? And let me like spell it out for you. Say, for example, you have like a data studio dashboard, right, built within data studio, or say a Tableau dashboard, which is connected to your BigQuery tables, right? What BI engine would be able to do is basically provide you a way to streamline all of your queries, run them in memory, run them in RAM using BI engine, and be able to get your results faster, right? Generally, how it would look like in a dashboard setting is you would have a dashboard, right? That dashboard would have a couple of filters and would have a couple of aggregations happening, and those aggregations more often than not happen in real time, right? Because you want like your dashboard to be updated in real time. And all of these queries, even though no matter how fast BigQuery is, collectively would take some time to be able to run, right? What you can do is basically streamline all of those queries through BI engine, right? And BI engine would be able to take those queries, streamline them, optimize them, run them in RAM so that you get your results as soon as possible. Sadly, we don't have a demo for BI Engine yet because it's more of a backend service. It's more of a managed service. But later on in one of our coffee and talk, maybe we can do a quick demo on how Data Studio looks like with BI Engine and how Data Studio looks like without BI Engine. But yeah, it's something to keep in your mind when you're building dashboards connected to BigQuery, because it sort of helps you fasten your overall dashboards and make them more responsive, right? Now onto the most important bit, right? Which is BigQuery ML, and this is something which I'm like super passionate about, right? BigQuery ML is something which is one class apart. None of the competition, none of the tools currently offers it, right? There was Looker which used to offer it, but Google acquired Looker. What BigQuery ML helps you do is it helps you create machine learning models, right? Straight out of BigQuery. So say, for example, you have a table within BigQuery, right? You have, I can take this for example, right? You have a table, unique transaction ID, transaction status, whatever. You can basically take these columns from BigQuery, create a regression model or a classification model all within a SQL query, all within the editor that you see on my screen, right? All within here, be able to train a TensorFlow model and then also run that model and also predict from that model, right? If that doesn't blow your mind, I don't know what will.
Yeah.
So let me quickly. So I had put this repo together a while back. It's in private. Um, I'm gonna make it public right now so that all of you can also look at the code um, as well. If I remember how to make this
You
private,
can check it out later.
yeah, make public. I just made this public. This is weber-western/ml on GCP. This has like couple of code snippets on how you build machine learning models on Google Cloud Platform, either using AI Platform or using BigQuery ML. Right now we're focusing on BigQuery ML, so I'm just going to quickly run you through the scripts. So in here there are scripts for training a BigQuery ML model, predicting from a BigQuery ML model, and evaluating a BigQuery ML model. Right. So let me just quickly copy this, right? Push it into my BigQuery console, full screen, and the lag is back. Okay, I'm sorry, my screen's again hanging up a bit, but I can just quickly walk you through what this query does. Um, Anyway, so you can, so all I'm doing here is I'm creating a model, right? I'm creating this model in a data set called BQML underscore tutorial. I'm naming the model as sample underscore model, right? And within the options, I'm giving that I'm telling my BigQuery ML flow, right, that this should be a logistic regression model, meaning this is a classification model, right? And then I'm basically selecting all of my features. So first is total transaction, right? What was the operating system, whether it was on mobile or not, what is the country, and what were the overall page views, right? And what I'm essentially trying to do is I'm taking Google. So sorry, let me take a step back. The data set is basically a Google Analytics sample data set, right, which has Google Analytics session, right? What these sessions do is per row it basically gives you certain information about who sort of visited your site, whether it was on mobile, which country was it, how many number of pages did they view, and so on, right? And using this data we want to see whether there would be a transaction or not, right? Which you can see here. Total store transaction is null. So it 0 means there was no transaction, 1 means there was a transaction, right? And this is like a classification problem. So I run this. I define my time period from 2016 0801 to 2017 0630. So I'm essentially giving roughly about 8 to 9 months of data, to 10 months of data, and I create this model. As soon as I run this, BigQuery would create a TensorFlow model, right? And this TensorFlow model would then be saved within BQML underscore tutorial dataset and as a sample underscore model. And then if I have to query this model, I can again write pretty much the same query, right? I basically select country and total predicted purchases and all of that, and then I run ml.predict, right? Everything remains the same. Just my table suffix changes, my query period changes, and I run the ml.predict model sort of code, right? And this basically predicts from the model which I stored in the BQML tutorial table, right? And this is pretty cool, right? So now you don't have to go through like TensorFlow or and again, just a quick thing. This creates like a deep learning model, right? So it's optimized on your data set, right? It's a DNN, um, and there are also options for creating statistical models and so on. I'm not getting too deep into that, but just the very fact that just using like a very simple 18 line code or like 10 line code, you're able to create a machine learning model, save it, and then be able to predict it is very neat, right? And also like all of this training is distributed on BigQuery cluster, right? So it's extremely fast. So it would take like 15 minutes or 20 minutes to be able to create like a fully tuned model within BigQuery, which you can leverage. So yeah, I mean, I'm sorry I couldn't show the live demo, but head over to ML on GCP and you will find all of these queries here, and you can go through it and then run it possibly if you want to.
Cool, right? One
Yep.
of the best features that I love, yeah, as you said, this feature will absolutely mind blowing. You can create a linear regression model, you can create a logistic regression model, both binary and
Yep.
multiple, and you can also create a k-means, which basically means you can create a recommender system right out of the box without having to export your data anywhere. And even if you have like a pre-built TensorFlow model, all you have to do is like bring in the model and just run it on this console, and it scales the way BigQuery scales, right? That's beautiful. How and to see how it pans out, all using standard SQL. There were only two lines of two statements that said that, hey, I mean, yeah, just create model and just what, and just simply you're predicting the next moment, right? Okay, we will just this is the last section, right? We've
Yeah, so
already,
I actually skimmed through all the best practices and I just got the final slide up so that we don't like spend a lot of time on each and every slide. So this is the final view, if you can see my screen still.
yeah. Right. Uh, okay. So Aman asked a question that what about the normalization features?
Yeah,
Okay, let's
BigQuery.
talk about nested and repeated fields. Uh, I think so these two are kind of combined points in my the way I see them. Maybe Vaibhav can add to them more, right? BigQuery performs better when data sets are denormalized, right? Because in a normalized data set, there are so many hops that a query would have to do if it has to scan through multiple, right? Think of it, right? When let's say if you have a normalized data set that says that has a foreign key, and then you and that foreign key is a primary key of some other data set, you're hopping onto that data set, and there's so many reads that are happening at the point, which will definitely reduce your IO, right? And then it is also hardware wise it's expensive because now you're amplifying, you're pushing in more cores, you're pushing in more memory just in just trying to make it much more faster, and the way this is read is also different, right? If you see how columnar databases or row based databases process, uh, columnar databases are faster for this very reason, because the algorithm that is behind, the closer values get much more closer. I mean, values that are related get much more closer, which is why it's easier to read. So it works better and best, and when you have repeated columns, and when you have denormalized data. So even if, let's say, there are two rows and right, which are exactly the same, let's just say, right, if I have a date table that has uh, that has information about my family, just as an example, right? Everything would remain the same. Our address would remain the same. Phone number, for example, landline would remain the same. A good chunk of details would remain the same, except for the first name, right? And if I have to query other data, if I only have to query that data, that is still kind of a repeated field, or I can nest that data, right? And just put it on one column. It's kind of beautiful to see what kind of fancy structures that you can create on BigQuery and combine them all. So it works better when the data is normalized and nested and repeated. Whenever data is nested, you have to expand it before you can read it through, which again forms repeated fields. And yeah, maybe Weber can add
Yeah.
to it and it's better.
Yeah, just want to like add like two quick things, right? So BigQuery is an analytical data warehouse, right? Generally, analytical data warehouses, even if you look at any other analytical data warehouse, would be extremely good at aggregating data, right? But as soon as you put in a lot of joins along with it, right? So when we say denormalize data whenever possible, what we mean is that don't have like a star schema or like a whatever other schemas that we have, right? Don't have like those kind of schemas wherein you're sort of connecting with the multiple tables here and there, right? And joining them in real time and then getting something out, because uh, BigQuery is very fast for single table operations. Just reduce like your overall joins to as low as possible, right? Second is that you don't have to, like, say for example, if you have a complex data type, right? Say you have a JSON data type, or if you have an array data type within your BigQuery table, you don't have to like flatten the table out. BigQuery works quite well with like nested and repeated fields. So just like you can leverage dot operator to be able to get to whichever field you want to, and then you can use struct and array operators within BigQuery SQL to be able to traverse through those repeated fields and nested fields, right? So BigQuery is quite good in that sense. Um, the third point is that avoid using select star from, right, when you're using BigQuery. And now I'm sorry if you didn't set context before, right? Like right now we're in the last stage of the entire talk or the conversation. We're talking about best case practices that we have kind of seen in our client deliveries and so on. And this is the third one, right? That avoid taking all the data together to your BigQuery SQL queries. What that does is it unnecessarily adds more memory load onto BigQuery. Just take whatever columns are useful. So always like make it a practice to never do select star from. Like always put like couple of columns in there to reduce the overall memory load that your BigQuery slots get, right? Second, again, sorry, fourth is again, like this is something which is common, right? That reduce data before using a join, right? So basically your first query should have all the where clauses in your table, right? Reduce everything there, right there and then perform joins should you have to perform joins, right? And that is in a case where you can just not avoid a join to another table, right? um, yeah, I mean the fifth point is pretty much self-explanatory, right? Avoid repeated joins and subqueries, because if you do it again and again, or like do a lot of self joins, that just does not make sense. Makes the overall process sequential rather than parallelizable. So yeah, right. The last one is probably the most interesting one, right? Because we were talking about that we were talking about the fact that JavaScript UDFs are something which are probably the best ones, and like is like a trend setter rather than like because no other sort of competitive service has like a feature like this, and you can augment your existing queries using JavaScript UDFs. It's all true, but right now we're talking about how you can like optimize your queries further. The fact is that every time you use a JS UDF, what happens is that you have to instantiate like a JavaScript session, right? For your query to run, and you have to do it for each and every distributed slot that your query runs on. So that kind of adds on to the overall time taken by your query to run on BigQuery, right? So this is just to avoid that. If you cannot avoid it, that's totally fine. But there's some bit of overhead that's added when you use JS UDFs. What you can possibly do is, instead of using JS UDFs, you can use SQL user-defined functions. You can convert those JavaScript user-defined functions to SQL UDFs, and those would work pretty much the same way as your normal SQL, uh, code does. So yeah, you can possibly do that. With that, Pranay, do you want to add something here?
No, I think that's very well said. And there's only just one point that I would like to add, which is about control projection and reducing data before join. Those are actually anti-patterns. So
Yeah.
which means yeah they're definitely in best practices, but I mean there's a common tendency to do that. Those are actually anti-patterns when it comes to columnar databases. I had this one query that came up to me at my job that said that, hey, this query 6 months ago was taking um, maybe under a, maybe under 5 seconds or so, and now it's been running for 6 hours. What happened? They're basically trying to join a smaller table with a much larger table, and that larger table had kind of expanded to, I don't know, 2 terabytes because it was getting streaming inserts. So yeah, it's actually an anti-pattern, and you'll run into your own problems that you created in the first place. So don't do that. Yeah, and these are the best practices you should definitely follow with BigQuery. Not only they'll save you cost, it's also better for your performance aspects. Uh, so yeah, that's it. Right. We can take up questions now.
Yeah.
Um, Aman has a question that says that if, like we talked about, if that BigQuery works best with denormalized data, uh, his counter argument is that wouldn't normalizing the data reduce redundancy and hence make it faster to access and process the data?
Sorry, where's that question? I'm trying to figure out. Wouldn't normalizing the data reduce the redundancy and hence make it um, so Aman, just to take just to try to answer your question, right? So um, when you mean normalizing your data, are you talking about normalizing it in the sense of flattening the data within a particular table, or are you talking about normalizing it in the sense that you have multiple tables within your warehouse in like a star schema or like a hub schema or something like that? Because if you're talking about
I think,
uh
yeah, I think it's latter in more all likelihood. That's what I'm assuming.
Oh, okay. So the thing with like
Yeah.
uh, when you reduce your data, like so BigQuery does not have a problem with the size of your data, right? What it has a problem with is basically those joins, right? So you have these two tables, and when you're trying to like join them, that's when BigQuery sort of starts struggling, right? Because it's not meant for um, that kind of workload, right? So it's always recommended to not have joins, right? I agree that you reduce your data and so on and so forth, but BigQuery spends more time in joining than in crunching your data sets. So in case of BigQuery, this is kind of redundant. What you're saying would be true for like a transactional database, right? Say you have like an Oracle database, or if you have like a MySQL database. In those scenarios, it would be sure, it would be true, and it would help you sort of optimize it. But BigQuery is not a transactional data set, database per se. So yeah, I hope that answers your question.
Yeah. Right. Okay. There's another query regarding recommendation engine we mentioned ago. What is the best practice or approach that needed to be taken while implementing in GCP? Um,
Which are you talking about, BI engine or what's the recommendation?
it's a recommendation engine.
Oh, okay. So there's it's a specific doubt. So it's okay. I can probably take that up in terms of machine learning, right? So say you have a working model, right? And if it's built on GCP or off GCP, what you basically have to do is take those um, take those model artifacts, right? And then you can do a couple of things. The first thing is that you can deploy this model on BigQuery, sorry, on AI platform, right? You can deploy this model as an AI platform predict job, and it will give you like an API which you can ping, and then be able to get your then be able to get your sort of predictions out, right? Second is that you can deploy this on GKE, which is Google Kubernetes Engine, again as an API using TensorFlow serving. Then there is then you can also deploy this on Google Cloud Run, which basically means that it's basically a managed Kubernetes API offering where you can push your model in and you can deploy it there. But pretty much, Yogesh, this would depend on what your particular use case is. I would recommend if you want to just quickly test your model out and like predict from it, then just deploy it as an AI platform predict job. But if you want to deploy it for masses, then maybe you're looking at GKE or like simply just writing like a simple Python Flask API around it and deploy it on um, what's it called? Google Compute Engine. I hope that answers your question. Um, then let's Abhimanyu, you had a question on, can you shed some light on underlying architecture that makes it possible to for querying BigQuery? Let me Abhimanyu, we can do one thing. We can put the white paper that Google used for coming up with BigQuery and Dremel, which is the underlying sort of tech behind it. We can share that with you, and yeah, we can, and maybe if you have any questions, we can take it up with on the chat, because there's like just the architecture itself is quite overwhelming. It uses map reduce and all of that, and then it gets quite daunting as we get going. But I can definitely answer your question as, um, can you give some examples of usage of BigQuery in real world projects? So if you use Spotify uses BigQuery for their analytics purposes. Their, you know, when 2020 kicked off, there was this 2019, what's it called? The most, yeah, there was this like album that was made for each and every person, which was that which songs did you play the most in 2019? Spotify basically built the largest data flow job ever to using BigQuery to be able to get that data and then be able to sort of give those insights. Twitter uses BigQuery for their archival and their purposes. Then I think JP Morgan Chase uses BigQuery for their stock market analysis and all of that. Uh,
Yeah.
Philips does it. There are like multiple clients. If you just go on gcp.solutions, you would find so many clients who are using BigQuery. Pretty much all the clients use BigQuery, first of all. So you can find
Yeah.
what they're doing, how they're doing it, why they're doing it, and so on.
One of the most interesting insights that I got about BigQuery was that out of the top 20 customers for BigQuery, 14 of them were not even on Google Cloud. They were using some other
Yeah.
cloud platform. They were simply using Google Cloud for BigQuery because that is the kind of tool that they could not find out anywhere else.
Yep.
Just yeah, as an example of usage, right? It's a large scale petabyte scale data warehousing solution. If you want to do a TLDR.
Yeah.
Uh, yeah. Uh, and okay, so the other question was that what is the architecture? Abhimanyu asked. Again, a TLDR would be that they have offloaded the storage and the compute. So basically, storage remains intact and the compute is able to scale, which is why they are able to do it so fast. Again, the white paper would definitely offer much more than what I'm telling. But at baseline, the storage is separated from compute, and compute is much more faster to scale than storage. So with it again map reduce kind of mechanism wherein data is concentrated and there are multiple nodes acting on it at the same time. um, if you really want to break it down, think of it that if there are multiple operations being happening, there's a where clause, there's a join, and maybe there's a sum somewhere happening. All of these are distributed to separate nodes, and data is at the end accumulated at one point in time. So you basically get a view, uh, you basically get an output at the end and not separate stages. You can actually see them what data went in and what data came out in different stages. And whenever you run a successful query, you have that kind of visualization available to you. So yeah, that happens. BigQuery is a data warehousing solution. Bigtable is again a petabyte scale data, uh, say it's a NoSQL data analytics solution, much more suited for lower latency. Google search runs on top of Bigtable. Um, it actually uses a couple of, but yeah, Bigtable is an important component there uh, because yeah, it you're right. I quote this example a lot, that no query in Google takes less than a second, takes more than a second, right? Uh, and that is because there's an interface of Bigtable in between, which is why it's able to query it so far in sub-second latency. Uh, that is where Bigtable comes in. Fun point: Bigtable is now also available for smaller workloads, so you're not bound to utilizing only 3 nodes today. I mean, three starting 3 nodes. So, yeah, that's there. Okay, so
Yeah,
Aman
I just
has a
want to quickly take just want to quickly take Biswanath's question because that's something a lot of people would have. His question is, if something goes wrong within our production environment when you're running a query, can you roll back? And Biswanath, you can, right? So say for example, if you have an insert job and if that messes around with your table, you have a concept of table snapshots, and you can basically go back to your last snapshot, right? BigQuery keeps snapshots for every day almost at a minutely level, and you can also fine tune it to secondly level, and all of that. It will create a snapshot for you, and you can go back to that snapshot, and your overall table would be reverted back to that um, good quality table.
right. Aman has this question that says, just to confirm, the normalized data works better with BigQuery since we don't modify the data and only end up reporting it. Um,
It's yes
kind of.
and no. Yeah,
Yeah.
it's yes and
Yeah.
no. Uh, Yeah, I mean, you do modify your data sometime, right? But then the thing is that again, this stems to like the way columnar databases work, right? Columnar databases work on at like a column level, not at a row level, right? So they would do your aggregations really fast. They would run operations on the entire column really fast. Whereas like when it comes to transactions, or like when it comes to like a transactional database like a SQL server or like a Oracle server. I always come back to SQL Server and Oracle servers. I just don't like them. But yeah, when it comes to those are like transactional servers, right? So over there, you like those queries also work. Some queries work on column level, but more often than not, you make updates at like a row level, and all of that. So the purpose is very different from what you're using BigQuery for, and what you're using, say, a transactional database for, right? So that is why you can modify data, right? It's not that you cannot modify data in BigQuery. It's just that the reason why you use BigQuery is not just for keeping like a like an archival process on your um, um, for your warehouse, but also for like reporting, also for like creating insights out of it, and for example, as I mentioned, you can create machine learning models on it, and so on and so forth. Basically, you're trying large scale applications on it.
Right. If I can give like a basic overview of how these role-based and columnar databases, data processing solutions work. If you have three rows, right, and with 3 columns, let's say the columns are A, B, C. If it's a row-based system, and if you are to query them, it would be arranged in a row-based one would be arranged in ABC, ABC, and ABC, right? But if you do it in a columnar level, right, when it comes down, the tree would be arranged in the format of AAA, BBB, CCC, which is why when you the order does not matter here, right? Whenever you fetch data from BigQuery, it does not matter in what order data was inserted. It'll fetch whatever it can at the quickest, and then it'll report you, which is why, yeah, it's much more faster because you're only, let's say you're only interested in rows A and C, right? B would definitely would not be counted at all. So which is why that can be completely ignored, and uh, it's able to process things faster.
Yep.
Yeah, that's kind of, yeah, how columnar databases work. Right.
Yeah, I think if we
Okay,
if we if we have any more questions, maybe we can like take those offline on chat or maybe on Twitter.
link.
We'll put our Twitter handles, put our LinkedIn handles. If you have any questions, maybe you can reach out there. I know this was originally intended to be like an hour-long session with Q&A. It's now become like an hour and a half long session. So sorry about that. It's more for Pranay and I to work out our timings better and not get sort of
Yeah.
all enthused in like what's BigQuery, all technicalities and all that jazz. So we'll work on that. But thank you so much for tuning in, and for all of those who will watch this in future, thank you so much for watching it all the way through the end. And yeah. We'll catch you next Saturday. Till then, if you have any questions, reach out to us. If you have any suggestions on what GCP services should we take up next, do shoot them on the comments. And yeah, like, share, subscribe.
Cool. Yeah.
Cool.
Catch you all later.
All right, perfect.
Bye.